Recall the definition of rigid bodies. There are hard, solid bodies that have definite shape and size. It is an idealized body that is immune to any form of deformation. So, can we consider rocks as rigid bodies? In the real world, are such solids perfectly rigid? What are you seeing here are solid layers of rock that have been bent into curves over thousands of years by immense stresses applied on them. So, clearly, even rocks can bend or break under enough forces. This means that in the real world, no solids are perfectly rigid. Let us consider a thought experiment. You are asked to climb a wall that is 10 meters high. There are three kinds of ladders given: a wooden one, a ladder made up of styrofoam, and a third one that is made up of steel. What would you choose and why? Without a second thought, you would have chosen the steel one. All the given materials are solids with a definite shape and size, but still you went for the steel one. So, there is a clear distinction between the three. Some solid property of steel made you take that decision. Steel is less probable to break or undergo any form of deformation. That's why you chose steel. But what exactly does deformation mean? Consider a steel spring, for example, as you can see here. We can stretch and compress the steel spring by exerting some forces on it. This means that its shape and size can be changed by the application of some force. So, deformation is the change in the shape or size of a solid object. But what is more fascinating is that the steel spring regains its original form as soon as the applied force is removed. This means that although it gets deformed, it has the ability to regain its original configuration. This property of solids is called elasticity. The term elasticity can be defined as the property of a body by virtue of which it tends to regain its original size and shape when the applied force is removed. The deformation produced here can be termed as elastic deformation. Elasticity is also defined as the ability of a solid to resist deformation when it is under a deforming force. This is the property which made you choose the steel ladder over the other two. What does it imply? This implies that steel is elastic. That is, steel can withstand large amount of force without deformation. Speaking of elasticity, it is necessary to speak about the property that lies on the other end of the spectrum. Consider a ball of clay. When some force is applied, the clay completely changes its configuration and does not show a tendency to change back to its original form. Such substances are called plastic substances, and this property is called plasticity. So, plasticity involves permanent deformation from which there is no recovery. A very common example of a plastic material is clay. Its plasticity makes it extremely useful to us. Perfect elasticity means the material suffers from zero permanent deformation under any value of force. These bodies store and release elastic potential energy perfectly with no losses. There are no materials yet discovered that are perfectly elastic. For example, we can say that carbon steel is highly resistant to deformation, but some very large force would be able to deform steel. There are materials like phosphor, bronze, and quartz which approach perfectly elastic behavior. Perfect plasticity means zero tendency to resist external forces. Again, no real material shows this property. Okay, so we have already established that elasticity is the resistance against external stress. But what exactly is stress? Do all materials experience the same kind of stress? Or do materials experience a combination of different kinds of stresses? We will find the answers of these questions in the coming videos. Let's summarize what we have learned.
Manorama Horizon. Learning made simple.